Okay, this is another nice long report by the McKinsey company, which provides some pointers to the energy transition and more region-specific agenda items for near-term action going up to 2030. So we have looked at the global picture of net zero transitions required. We have looked at net zero emissions, energy systems, and so on. This offers a bit more details on what are the region-specific issues in terms of carbon intensity, fossil fuel dependence, need for deploying renewables, and the acceleration needed to meet the commitment goals to global warming targets, or NDCs, and so on. And also considers the country's abilities or resources in terms of precious minerals like cobalt, nickel, copper, lithium, and so on. I'm not going to go into those details. It's a very long report, as I said. I'm going to just condense it and make a few points, and obviously the report is available online. You should go read it if you're interested in these sorts of details. The report basically divides the countries into 5 main archetypes based on key energy transition characteristics. So short-term risk, relative energy security, and CO2 intensity. CO2 intensity is important. You want to reduce fossil fuel dependence. You want to also reduce carbon intensity, so energy intensity of the GDP and carbon intensity of the energy, and so on. And doing that, you get 5 classifications, as we said. Affluent energy secure countries, affluent energy exposed countries, and large emissions intensive economies. And in the next chart we will look at developing naturally endowed countries and then developing at risk countries. So this is the next chart here that we'll go into. So the axis here goes from higher to lower in terms of short-term fossil fuel reliance and emissions intensity. So both have to be looked at in terms of the need for near-term actions. And this is the disposable financial resources and capital in terms of per capita GDP in dollars. So obviously intuitively you know that China and India are down here in the scale, or in this phase space, in terms of fossil fuel reliance and emissions intensity being higher and per capita GDP being lower, for example. Whereas the affluent energy exposed countries have higher per capita GDP and lower short-term fossil fuel reliance and emissions intensity, but they have energy exposures that have to be considered. The countries here, so here you have China, India, South Africa. Here you have Japan, South Korea, Poland, Chile, Greece, Hungary, Portugal, Kuwait, Spain, Czech Republic, and so on. So you have many Middle Eastern countries here as well, like Kuwait and Emirates. And you have progressive EU countries like Germany and Israel, also from the Middle East. And you inch up into these affluent energy secure countries. So Netherlands is on the border right there, similar to Portugal from this side. But you have Saudi Arabia, which is affluent and energy secure, and United States, which is a very high GDP and energy secure affluent country. And of course you have Denmark, Sweden, Canada, France, Finland. So France, for example, has fossil fuel reliance and emissions intensity scale ending up here, but it also has lots of nuclear resource, which is considered a renewable energy. So we will look at various issues that are associated with energy transitions for these types of countries. Looking again at the developing naturally endowed countries, you have countries that have fossil fuel resources or renewable resources as well, in terms of Argentina, Morocco, Egypt, Philippines, Peru, Brazil, Mexico, and Uruguay. So the per capita GDP here is higher for these countries which are developing but also naturally endowed. and you have countries that are developing and at risk. You expect African countries down here, so you have Kenya, Senegal, Nigeria, Ghana, Honduras from the Western Hemisphere, Indonesia, Vietnam, Philippines straddle the boundary here between being naturally endowed and at risk. Colombia, Thailand, Malaysia is down here, rich but at risk from fossil fuel reliance and energy intensity. Okay, so the share of renewables in primary energy consumption globally has risen, which you think is a good sign, but if you keep in mind that the CO2 is still increasing continuously, it's not such a great transition yet. But fossil fuels still predominate, obviously because of that. Primary energy consumptions in exajoules, we are looking here in 2011, 16, 21, and you can see that oil has somewhat reduced, coal has reduced, but not nearly enough as it should in terms of its impact on not only emissions and global warming but also health and so on. Natural gas has increased. There are various reasons, especially going into 2021, and also some of the European countries are beginning to mention natural gas as a low emission fossil fuel, which gives them a little bit of wiggle room in transitioning to renewables and heading towards net zero. So you go away from oil and coal and you go to natural gas, call it low emission, but that's just a trick that's not really good in the long run. So here is nuclear energy, almost the same. Renewables have gone from 9% to 11 to 13%, but that's not really a whole lot, and you consider the trajectory we need to be on. In terms of installed capacities in gigawatts, total renewables to have gone from 1330 to 3064, so that's quite a nice jump there. Out of that, solar and wind have gone from 294 to 1674, so that's 55% of the renewables, which is good energy. So others include hydropower, marine bioenergy, geothermal energy, and so on. So keeping that in mind, where do we need to go? The world needs to bend the curve to achieve net zero emissions. So we are now going to 2030 in terms of the global warming targets, where we need to be by 2030. So these are net energy related annual emissions by scenarios in metric gigatons of CO2 equivalent per year, 2022 to 2030. You remember CO2 equivalent includes non-CO2 greenhouse gases, and we are looking at various countries, and it's not even very important to see which countries are doing what, but looking at the gigaton CO2 equivalent emissions per year, the current trajectory is here for 2030, and that in the current trajectory would imply a 2.4 degrees C rise in global temperatures by 2100, while the achieved commitment scenario would lead to a rise in global temperature of 1.7 degrees C by 2100, which is below 2 degrees C, which is much better in terms of the global warming targets. Of course, 1.5 is what everybody is dreaming about, but as we have said before, these rely on technological promises of carbon capture and biofuels and so on, which may or may not be realized, unfortunately, as of now. Scalability, etc. Projected gap between achieved commitments and correct trajectory here scenario by 2030 is 2.4 gigaton per year CO2. Okay, so this is what we have to hit in terms of accelerating the renewable energy installations. So the acceleration in renewable energy installations required to achieve commitments varies among regions, and the main purpose of this report is to look at those region specific issues for near-term action to 2030 in terms of energy transitions. So these are the countries looking at Africa, Australia, China, and so on. Looking at 2016 to 2021 in terms of average yearly installed capacity of solar in gigawatts, and then where they need to be by 2021 to 2030 in terms of, again, gigawatts installed capacity, and the acceleration required in installations to be on track for the transitions to the committed global warming targets or Paris agreements, NDCs, and so on. We don't need to go into the details, but you see that Africa needs to accelerate by 11 times. Australia is much better. There are, like for example, Japan needs to only accelerate by 1.4 times, whereas China has to go 1.7, so it's done pretty well, whereas country like India has to accelerate 8.5 times, which is lagging quite a bit in terms of where it needs to be by 2030. Obviously, these also imply for their own energy security they need to do this and reduce their dependence on fossil fuel. Looking at the other part, average yearly installed capacity of wind in gigawatts for 2016 to 2030, it has to be 16 times for Africa, Australia almost 4 times, China 1.8 times. So China is doing remarkably well in that sense, but India needs to accelerate 5.7 times, and Japan here needs to go up 8.3 times, and even the US has to go up 2.6 times, and in solar needs to go up 3.3 times, which is worse than China, for example, because China has been leading the transition to renewables in terms of deploying solar and wind for its own energy security, and not necessarily always for global action as such. This is a complicated figure with the numbers here, which we will not get into because I don't want to get into the details here. But a massive increase in deployment of renewable energies will be needed to fill gaps between energy production and consumption. So we are looking here at production versus consumption for key commodities, exajoules per year in 2021 in terms of oil, gas, and coal. And then it's export and import. So you can see Africa here is producing 30.3, internally consuming 18.0, export implied is 12.3. But if you look at high import countries like China, European Union, and India, Japan, for example, they need to reduce the imports and of course accelerate the deployment of renewable to reduce their fossil fuel dependence. They also need to, of course, reduce the carbon intensity, and they need to, this obviously will also help them be energy independent, or at least buffer their dependence on market forces in terms of fossil fuels, which got clearly exposed during the Russian invasion of Ukraine, for example. The perturbations to the markets we have discussed in a couple of podcasts have been pretty massive and will persist for some time because the war shows no signs of going away anytime soon. So you can see that India and China and even Europe have massive work to do in terms of reducing their fossil fuel dependence and accelerating implementation of renewable transitions. The energy mix of regions differs substantially, although fossil fuels remain the prevalent source of primary energy. Primary energy consumption by fuel in exajoules in 2021, looking at oil, natural gas, coal, nuclear, hydroelectric, and renewables. Again, the idea is in this report to look at region-specific numbers. So here we are: Africa, China, Europe, India, Latin America, Middle East, Southeast Asia, and United States. And obviously China and India are booming economies, and they will continue to grow in their energy demand and energy consumption. And China is doing well in terms of nuclear, hydroelectric, electric, and renewables, but fossil fuels, especially coal here, remains a massive part of the primary energy consumption. Similarly for India, renewables are small percentage. So if you look at fossil fuel share versus emissions per GDP in tons of CO2 equivalent per dollar, fossil fuels remain high for every country. So even for a country like United States, which is rich and has resources, the renewable percentage is fairly small. Most of it is still dependent on fossil fuels. So obviously transitions are needed for all countries. As we already mentioned, countries can be ranked by three dimensions of the energy transition: affluence, short-term risk, and long-term opportunity. So these are the defining attributes going from low to high. And you have affluent, energy secure countries that we looked at, where affluence is high, short-term risk is low to medium, long-term opportunity is high. For affluent, energy exposed countries like Israel, Singapore, Germany, and Japan, affluence is high, of course, short-term risk is relatively high, and long-term opportunity can be low or high. For Israel, it's high in terms of wind, for example, and solar. Large emissions intensive economies like China, India, and South Africa have low affluence, high short-term risk, and varying long-term opportunity. None of them have high long-term opportunity other than South Africa. It has high short-term risk, high long-term opportunity. So for details of what these mean, you can look up the report. Developing naturally endowed countries: Morocco, Egypt, Mexico, Brazil. Again, low income, similarly developing at-risk countries like Nigeria, Venezuela, Indonesia, Thailand. Low incomes, various levels of short-term risks and long-term opportunities. Okay, so I will make this into two podcasts because this is a very long report and I have plenty of points to make, even though I'm being brief. So the chapter's third one looks at globally 8 sets of common actions that are needed for a more orderly energy transition. So I'll just read the main points, and each point has details in it that you can find in the report that I'm going to not put all down here. Physical building blocks: 4 of the 8 sets of actions we identify fit into the category of physical building blocks. Streamlining access to land, accelerating permitting, and simplifying processes to accelerate time to deployment for renewable and clean tech. This is true for across the globe, and then we'll look at region-specific recommendations as well, just for India as an example. Secondly, modernizing and repurposing legacy infrastructure and creating new assets to accelerate the integration of renewables and clean tech into the energy system. So there are other details here which I won't read. Strengthening global supply chains to secure critical raw materials, components, and labor competencies. So this is an opportunity also to for new employment, for example. Decarbonizing the industry and transportation sectors by investing in new technologies, electrification, and energy efficiency. Okay, seem obvious, but still we need to put them down. In terms of economic and societal adjustments needed, 2 of the sets of potential actions are in the category of economic and societal adjustments. Fifth one here of being in the list: limiting and mitigating emissions intensive generation to reduce the carbon footprint of fossil fuels and lower the risks for stranded assets. So in terms of leaving natural gas, coal, and oil in the ground, which is what we call stranded assets, we need to limit and mitigate emissions intensive generation so that we can use fossil fuels for the energy transition without making the carbon footprint worse and worse. So the energy intensity has to decrease along the way as well for production and for economic growth. Managing economic dislocations to promote energy affordability and create fair opportunities for affected and at-risk communities. Okay. Finally, governance, institutions, and commitments. The final 2 sets of possible actions are in the category of governance, institutions, and commitments. 7th one then, developing stable and attractive remuneration frameworks, market designs, and offtake structures to encourage investments in renewables and clean tech. So you want the financial industry and the investment community also to move towards green, and there are networks like the Network for Greening the Financial System and so on, which are pushing in this direction. There are impact investments which look for investments in green projects, and corporations and so on committing to net zero, etc. But here we are talking about commitments towards the energy transition. Finally, scaling frameworks and standards to measure carbon intensity of energy and final products and develop a global new carbon economy. So that's what is needed. So investing in developing and modernizing the power grid will be crucial to ensure that areas with high potential for renewable generation are integrated and connected with demand centers. So grid reorganization and modernization is an issue everywhere, including rich countries with resources like the US or Japan or wherever else. So let's leave this podcast here and come back and look at regions and how they need to take near-term climate action or near-term actions for energy transitions to hit the goals of global warming target commitments by 2030. Okay, so let's come back and do that in the next podcast.